Hello and welcome. Well, I took a couple of weeks off from doing any videos. Had some catching up to do around here, a little bit of remodeling, and I also cleared a spot out back for one of those portable sheds. That way I'll get this car out of the middle of my shop. Car's been a lot of fun. The weather's turned kind of cold now. But anyway, the videos did good, but I had a lot of questions and I thought I'd address one of them. Let me show you what I'm talking about. Okay, one of the big questions I had was how I did the wheels. And I kind of messed that up on the first video. I kind of jumped around on it and it was hard to follow. So I'm going to see if I can't do a better job. This is one that I messed up and changed the direction. I had to buy another wheel. So I'm going to use it to show how I modified it. Unfortunately, part of it's already been modified. There was a tube sticking up about this high that held a bearing right here and a bearing right here. And I removed part of that tube, which I needed to do, and I need to do for this current method of modifying, but it's already removed. And I'll show you a little clip right here on how I removed that tube. Okay, now I got a piece of 1/2-inch stock roughly cut round. I'm going to bolt that in my chuck and turn this round so it's a snug fit right there. That's the first step. Okay, I've actually done this quite a bit over the years. Turning a round disc in the lathe, it's a convenient way to really get a round disc. I use the head of the bolt behind the jaws. And it allows me, with a few washers, to tighten that disc down and turn the outside round. Okay, I'm either going to have to put it in back gear and slow it down a little bit, or take smaller bites. I'm going to try back gear. The surface speed of that diameter is fairly fast. Okay, I measured the wheel, and I need to go 196 thousandths further. A little heat going there. I think I may have gone a little bit small on this. Yep. Ideally, that needs to be a really good fit, but this is going to work fine for the demo. And you could probably put some Loctite in that and get away with it, but it's better if it fits tight. So now we got to bore that hole to 3/4 inch. Now I got to bore that to 3/4 inch, and I think I'll use a drill and then a boring bar. Well, my battery went dead. I finished boring that to 3/4 inch, and I'm turning what'll be facing the inside of the wheel, just turning the mill scale off it. And the reason I'm doing that is because I got a weld to that. Okay, now I'm going to make a little groove there. I'm aiming for 2 3/8, which is the outside of what I'm going to weld on there. Very close. Okay, in the bottom of that hole there are 3 reinforcements. And what I'm going to do is cut 3 notches in this pipe so that it engages those reinforcements. Right now I need to know the length of that pipe. And it needs to be a 1/2 inch lower than this ledge right here. So I measure down to the bottom, put the pipe about where it's supposed to be, measure down to the bottom, and then subtract the 1/2 inch will be about right. Okay, it's 2.2 inches. I'm going to call it 2.1, subtract a 1/2 inch. Make it 1.75 inch. Okay, I got the pipe chucked up in the lathe chuck. I'm doing 2 things here. I'm just truing up the end a little bit, but I'm also cleaning up the side right here because I'm going to TIG weld that. Okay, now I need to measure the height of those reinforcements. And it's not real critical. I'll make the notches considerably deeper. Now I need to cut 3 notches in here, 7/8 of an inch deep. So I'm going to touch off here, touching right there. Zero my knee. I need to go to 120, and that'll be 1/3. Okay, let's see if this fits. No, of course. But it's a little bit too long. Okay, try it again. Perfect. So, remember I made that little notch right there? Line that up right there and weld it to it. Okay, I probably could have just tack welded that, seeing as how I'm not going to use this wheel anyway. Could have also used my rotary table, which would have made it a little easier, but it's good thick steel. I had the amperage turned up and it was easy to weld. Okay, it fits perfect, but you'll notice it's got slop like that. Well, what I was worried about is these notches hitting one of the three reinforcements before the other. And if that happens, all the torque from the axle is going to be on one reinforcement instead of all three of them. So to counteract that, I've got this stuff called Tough Cast 75D. And as far as I'm concerned, this is really good stuff. So I'm going to mix up some of that, pour it in there, and drop that in. And in hindsight, I should have left that sticking up a little bit more, just so I could fill it up a little bit fuller, and it there wouldn't be any chance of it running over to the other side. I put tape on the holes that were not supposed to be there. Anyway, you mix up this Tough Cast and give it a try. This Tough Cast is 6 to 7 minutes work time. I made a line on the side of the bottle. Not exactly the most accurate method of doing that. Interesting that it turns white. I assume when it's a consistent white, it's pretty well mixed up. Looks like I did good. I don't see it running over in there. Well, we're waiting for that Tough Cast to dry. I'm going to cut off a bushing here that I made for the other side of that wheel. It'll be clear when I get to that point, but if you're interested in one of these cutoff tools, I've got them on my web store. I don't remember the price, but I'm going to knock $10 off. I got 3 AXA and I think 8 BXA, so. I've sold quite a few of these, and quite honestly, I've had all good reviews. Little needle oiler is amazing. You put it right down in the slot you're cutting, and you don't have to use very much oil. It's not slinging everywhere. I wouldn't say it's super fast. I don't know how much faster I could have gone, but it's drama-free. Okay, that's set up good. I've got this leftover axle that I messed up on the car. I made it a little bit too short. Normally I would cut a keyway in this 1/2-inch piece before I installed it, but I don't have any intention of using this wheel. Anyway, slide that through there like that, Here's that spacer I cut off yesterday. Yeah, let's see what this tape, see what the, oh, that looks nice. Heck, this wheel might be usable now that I've plugged that with epoxy. This Tough Cast is pretty good stuff. Anyway, that's a good drive wheel right there after I cut a keyway in there. In my opinion, the Cycle-Kart enthusiasts could use this method for front wheels, using front wheels from a CT90 Honda as a drive wheel. So far I've had no problems with my Buckboard Flyer driven with a 6.5 horsepower. Also, if you were using a back wheel, at least from my understanding, the recess in this wheel, on a back wheel on the CT90, has got a recess on both sides. One side's a push drive and the other side's a brake. You'd have to put a plate and do the same thing on both sides. Normally, the Cycle-Kart guys clamp the plates together with 3 bolts like I was trying to do here. And in my opinion, it probably weakens the wheel a little bit, maybe not considerably, and maybe it works fine, but it's just an alternate idea. Anyway, that about wraps it up. Thanks for joining me. Be sure and subscribe and ring that bell. Also, check out the links for my cutoff tools. I've dropped the price about $10. Hello, and thanks for joining me. Well, it's going to be a short little video. It's basically just to announce that I've got some more cutoff tools in stock on my web store. The first batch went incredibly fast, and I appreciate that. Thank you. So I want to outline what you need to do to succeed when you're using this tool. It's pretty simple to use, but let's get into that. Okay, first thing we got to do is establish the feed rate. And to do that, well, first of all, the feed rate needs to be between 1 and 2 thousandths per chuck revolution. My cross slide needs to go in 1 to 2 thousandths for every chuck revolution. But most lathes do not have that indicated on the quick change, and you got to calculate that. So the way to do that is I put a piece of tape on here, and I got it in back gear, so it's running pretty slow. I've engaged the cross slide. And I can lay my finger on there and I can feel that tape there. Then I look over here on my dial and I go to the next hole number and I start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That moved 10 thousandths and I got 10 revolutions on my chuck. For my lathe, that's an ideal feed rate. That's 1 thousandths per revolution. You can go up to 2, but my lathe cannot handle that. The belt starts slipping. So the next step is to set the surface speed per minute. And it needs to be at or a little bit slower than the calculated speed. For high-speed steel, which is what you want to calculate it for, that's 100 surface feet per minute. On 5/8 stock, that calculates to 600 RPM, I think. And my lathe doesn't go 600. It goes that fast. It's just, it'll be too fast. So I'm going to start at 440 surface feet per minute. Like I said, a little bit slower is fine. Faster usually doesn't work very good. First thing to do is set the tool height. You can have it very slightly high. Just pin a rule between the tip of the tool and your stock. And if this is vertical, you're on center. That's a little bit high. Let's go a little lower. Close enough. A little bit high sometimes avoids that little nub in the middle. Okay. This oil bottle is essential. You can put the tip of that oil bottle right in the cut and use a very small amount of oil and you won't have any oil slinging. Okay, let's give it a shot. A little bit of squeaking goes away after the tool gets under load. Auto feed really does work better with this tool, as long as it's not too fast. I don't know what the limits are. The limits for my lathe are about 1/1000th per chuck resolution. There we go. Beautiful.